we've been asked to convert 3 rectangular coordinate points to polar coordinates. And so I'm going to start each one by actually plotting the point because that's going to help me think about the angle. But I know the tools I'm allowed to use, the relationships between polar coordinates and rectangular coordinates. X is equal to r cosine theta, which is really just the definition of cosine. Cosine is x over r. Y is equal to r sine theta, the definition of sine. Tangent theta is y over x to help me find the angle, and that's the definition of tangent. And then finally, x squared plus y squared is r squared. And that was the definition of r when we wrote down these definitions, but it's really a distance formula statement and can be thought of as a statement about the Pythagorean theorem. So all things we already knew to relate rectangular coordinates and polar coordinates. All right, well, I'm going from x's and y's to r's and thetas, but first I'm going to plot the points. -2 comma +2 right up there. And just looking at that point, right, I'm right smack dab in the middle of the second quadrant. I actually don't think I need any help calculating that angle. I know that's 3 pi fourths. Right in the middle of that quadrant. Now I could set it up to where I was finding the tangent of theta is equal to y over x, 2 over -2 is -1, and then I'm thinking of the appropriate place where tangent's equal to -1, and that in the second quadrant is 3 pi fourths. All right, now I'm looking for a value of r, and r squared is x squared plus y squared. So let's see, I have 4 plus 4 is 8, so r squared is 8, making this 2 times the square root of 2 away from the origin. And so there I have my first polar coordinate. In part B, I'm going to kind of go through the same thinking. In fact, I end up in the second quadrant again. This time I'm at -2 times the square root of 3. The square root of 3 is about 1.7, so this is about -3.4 here in the x direction. So something like that. And again, honestly, with the y and the x looking so pretty with these, I think I know what angle that is. But let's see what happens. So I end up with a tangent of theta is equal to 2 over -2 root 3, which is 1 over -√3, which if I rationalize is a -√3 over 3. So I'm thinking that's the angle 5 pi 6. All right, again, I need to find a value of r to complete my polar coordinate, having this angle of 5 pi over 6. And let's see, x squared plus y squared is my r squared. All right, so let's see, I'd have 4 times 3 is 12, plus 4 is r squared. So r squared is 16, so r is 4. And there's my nice happy polar point. And this one, I don't think I need to think very hard about this one at all. The rectangular point 0, -6. That point right there, and I can easily spot that angle, 3 pi over 2, and I'm just 6 units straight down below the origin, so r has to be 6. And that's an advantage to applying the points, because in that I can just use some common sense to figure out what this polar point is without having to use any of my relationships. Though if I chose to, they would certainly work. All right, there we have it. 3 rectangular coordinate points converted to polar coordinates.